Before I get to the second way of testing Plutus contracts that I want to present today, I want to give a very brief introduction into optics and lenses. And there are various competing optics libraries on Hackage, but the most prominent and also most infamous one, and the one that the Plutus team decided to use, is called Lens. And it's authored by Edward Kmet, who is probably the most prolific contributor to Haskell libraries. And you see already on the Hackage page, the overview page of the Lens library, there's this scaring diagram. And there's a whole zoo of optics. So there are lenses and prisms and traversals and isos and whatnot. And here's a nice diagram with all the operations, or some of the operations, that the Lens library provides. And what optics are all about is reaching deeply into like hierarchical data types and inspect parts that are deeply hidden in a data type and manipulate them. Let's look at a very simple example that I provide in module Lens that shows the problem and how optics address that problem. So let's look at a company data type. It's just a new type wrapper around a list of persons with a accessor called staff. And I provide an underscore in front of staff that has no semantic meaning. So it's just another letter in this case. But when dealing with lenses, it's just convention to call fields with a leading underscore. So we have this company type, wrapper around persons. Then person is a record type with two fields, name and address, when name is just a string and address is of type address, again following this convention to use underscores in front of names. And finally, address is yet another new type wrapper around a string with accessor called underscore city. So there's nothing advanced going on. That's basically first week Haskell. And just as an example, I define two people, two persons, Alejandro and Lars, with name and address. And finally, I define a company where the staff consists of these two persons. And now the task is to write a simple function, goTo, that gets a string as argument and a company, and is supposed to create a new company, which you get from the old company by changing all the city names, all the cities of all the persons in the staff of the company to the given string. So if I apply that to IOHK and as string argument I use Athens, then in the end I should get a company with again two persons, again name Alejandro and Lars, but now both of those should have city Athens. And I mean, that is not very difficult. So you can easily do that. You don't need any advanced Haskell for that, but it's a bit messy even in this simple example. So if I implement this, go to there, so that's the new city and company, then I can use the old company and update the staff field in it. And this is, remember, a list of persons. So I write a helper function move person, and I map this helper function over the list, over the staff of the given company. And now in order to implement this move person, I take the existing person and then use record update syntax to change the address. So the name will be the same as the name of P, but I change the address. And what do I change it to? Well, I take the existing address and change the city name to there. We can try this out in the REPL. So I can first look at the original company, and it's as expected. And now I can apply goTo Athens to IOHK, and we see that the deep inside, I mean, a couple of levels down in the company, now we have changed the city names here to Athens and here as well. So we see that dealing with nested record types, even though conceptually they are not complicated, is just, or can be quite messy, because you always have to like keep the old fields in place and update the new ones. And if it's nested, that can be quite messy. And this is exactly what optics try to solve and make easier. The idea is to provide something like first-class field accessors. And in the end, it's almost as easy, or it's very similar to dealing with such data types in Haskell than it is in an imperative language with mutable data types using these dot accessors. So in C# or in Java, you could write something like company.staff.name or .address.city, for example. And with lenses, it looks very similar. So in that sense, when I introduced monads, I said that some people say that monads offer a programmable semicolon, because the semicolon is normally what's used in a lot of programming languages to chain statements together. And with a monad, you can customize how this chaining of statements works. And similarly, you can say that optics provide a programmable dot in the sense of an accessor dot, like in Python or Java. And in order to work with lenses, I mean, you can, if you want to, implement them by hand, but the lenses library provides some template Haskell magic to do that automatically, but that expects these underscore convention. And that's called make lenses, and then you provide the types for which you want these lenses. So I added these make lenses company, make lenses person, make lenses address. And the names of the lenses will be the names of the original fields without the underscore. So that's why there's this convention. The fields will have the underscore and the lenses won't. There's a way to inspect what code template Haskell writes at compile time from the REPL. For that, you can activate a flag called dedump splices. Now, if I reload, nothing happens. I think I must change the code. So let me just like this. Okay, and there we go. So this is now what template Haskell does. So we see the make lenses for company gives us a staff ISO. So that's a type of optic from company to list of person. Then make lenses person gives us an address lens from person to address, a name lens from person to string, and finally make lenses address gives us a city ISO from address to string. And ISO and lens are two different types of optics, but the convention or the order of type arguments is always the same. So you always have two type arguments, at least for these primed varieties. There are also more general optics with 4 type parameters, but these with 2. The first one is always like the big data type, and then the second parameter is the one you zoom into, the part. So it's called optics because you can have this mental image of zooming into a data type. So the staff lens or ISO provides a way to zoom in from a company to the staff, which is a list of persons. The address lens allows us, given a person, to zoom into the address field of the person. The name lens gives us a way to zoom in from a person to the name, which is a string. And finally, the city ISO allows us to zoom in from address into the city name string. And we can try these out. So if we take, for example, Lars, and want to use the name lens, one way is to just look at the result of zooming in. So I can do Lars and then use one of these funny operators provided by the lens library. That's this caret dot. And then one of the lenses. So let's take the name lens. I see I have to import control lens for this to work. Then I indeed get Lars, which is not very exciting, but at least it works. Similar if instead I use the address lens, then I get the address. So one very important feature of lenses, and that makes them so powerful, is that you can compose them. So using the address lens, I get from a person to the address. But the address itself is again a record type, which has this city field. And I can chain lenses together if they are compatible. So I have something going from person to address, and I have something going from address to string, then I can combine them. And the combination is actually just the usual function composition dot, which is actually very cute because it's exactly like in a imperative programming languages with the accessor dot. And there's some quite advanced type level machinery going on behind the scenes to make that work, but it works. So I can just do address.city, for example, and now I zoom in 2 steps. So from the person, Lars, first to the address and then to the city, and I see the result, which is Regensburg. And you can't only view the result of zooming in, you can also manipulate. So you can set. So if I want to, for example, set my name to something else, I could do the following. So here the syntax would be this ampersand, which is basically just function application the other way around. So the argument comes first and then the function. And now a lens, so name, and now colon tilde and new value. So if I want to, for example, rename myself to all uppercase, I can do this. And now the result is a new person where the name has updated. And again, I can compose. So I can do, for example, name dot, no, not name address, and then dot city. So I can reach into the person to the address and then deeper inside to the city and update the city from, for example, Regensburg to Munich. And it also works. So name and address are lenses, and lenses are, I mean, the intuition is that it's a part of a data structure, like the field in a record type. There's a different type of optics called traversables, which doesn't only zoom into one field, one thing, one smaller part, but into many simultaneously. So if you have a list, it would zoom into each element. So for example, I can use a list of integers, 3, 4. And now I can use the each traversable, which works for lots of container types, including lists, and can set every element to 42. And now I get a list with 3 42s. And the cool thing is that various types of lenses can be combined, again, with the dot operator. So for example, I had this IOHK type, the company type. So I can have IOHK and I can view the staff that we have seen before. But now the staff is a list. So now, for example, I can compose that with the each traversable. So now I focus on each element of the list, which is a person. Now I can compose this with address and that with city, and finally set it to, for example, Athens. Oh, I wanted to set, not view. So what I have to do is this. And this is exactly what this goTo function achieved. So I reach into the staff, then reach into each person in the staff, into each person's address, into each address's city, and set it to Athens. So instead of this relatively messy code I wrote before using lenses, I can simply update the name of the city of each person in the company using this. If we go back to the code, that's exactly how you can implement this goTo function using lenses. So you just update the company using this composed lens, or not, it's not a lens then anymore because there's a traversable in there, this composed optic staff.each.address.city and set it to there. And this is actually what I did here when I configured our test. So this default check options is of type check options, but there is a lens from check options to emulator config. And I just wanted to change the emulator config. So I can use this and then this emulator config lens and set it to the value I wanted to have. So that's how this works. And that concludes the brief excursion into optics. It's a fascinating topic. I love lenses and optics. I think they're really cool. You can do very cool things with that. But of course, it's not the topic of these lectures.